Hey guys, it's Miss Johnson here, and I'm here to bring you your notes on our learning target for graphing inequalities and absolute value equations. Um, so today, up at the top of your notes, we talk about graphing inequalities. So inequalities can be graphed in a similar way as linear equations and absolute value equations. The equation serves as the boundary area, but we need to decide where the solutions are, meaning where do we shade on the coordinate plane. Couple things to remember. When we have a less than or greater than sign, one without having or an equal to underneath it, this is where we put in a dashed line. And when we have that equal to underneath, this is when we put in a solid line. And then after we figure out what line to graph, we have to figure out where to shade. So there's a couple ways that we can graph this. The easiest way probably would be to put it in slope-intercept form, meaning we solve for y, get y by itself. We could also use in the intercepts and figure out that there, use the two intercepts to graph. Excuse me, both ways would work, but I'm going to put it in slope-intercept form. So I'm going to subtract 2x and I have 3y is greater than negative 2x plus 6. And then I'm going to divide by 3. And remember, in inequalities, we always have to check what we're dividing by. In this case, it's a positive number, so I keep the sign the same. I don't need to flip it. I'm going to have negative 2/3 x and then plus 2. So our slope here is negative 2/3. Our y-intercept is 2. We're not going to worry too much about the x-intercept here. Like I said, the x-intercept would be another way for us to figure out what that, where that graph would be, but I think this is just as well also. So to graph this on the line, okay, before I graph it actually, I'm going to make my decisions that I need to make. I'm going to look at the inequality symbol. I have an inequality symbol of greater than, and I'm going to decide two things, what kind of line and where I want to shade. In this case, this inequality symbol is greater than. So the line that I want is dashed. I want a dashed line. And I want to shade up or above the line. Okay, so let's go ahead and put this on the graph. I have a y-intercept of positive 2. I'm going to go up 2 places. And my slope is negative 2/3. So I'm going to go down 2 and right 3. Down 1, 2, over 1, 2, 3. I'll do that again. Down 1, 2, over 1, 2, 3. I'm off the coordinate plane a little bit, but that's okay. You can also go up 2 and back 3. 1, 2, 3. Okay. Then I want a dash line, meaning there's going to be spaces there. So my line looks like that. And all that's saying is that the solutions that are actually on the line don't count. That's just the boundary. But the things that are actually on the line are not solutions. They don't count towards the inequality. Then I want to shade above because all my solutions are greater than. So imagine yourself standing on the line and going straight up, anywhere on the line and going straight up. That's where we're going to shade. It's really helpful if you draw your line across the whole coordinate plane like I did so that you have a clear boundary of where you're shading. Okay, and that's my inequality. Let's try one more of those. In number 2, now I have negative x plus 2y is greater than 4. So again, I'm going to put it in slope-intercept form just because I think that's the easiest way to graph them. So I need to add x to both sides. That gives me 2y is greater than x plus 4. And then I want to divide by 2. Divide the whole right side by 2. Again, I'm dividing by a positive, so again, I do not need to flip the sign. It stays greater than. I have x over 2. That's like saying 1/2 times x, because we all know that the coefficient in front of x is 1. And my y-intercept, 4 divided by 2 is 2, so plus 2. So again, I have a y-intercept of 2. So slope here is 1/2. Y-intercept is 2. And again, you don't need to find the x-intercept. You could if you wanted to, but we don't need to because this is enough for us to graph the line. Let's make our decisions that we need to make when we look at the inequality symbol. This inequality symbol again means that I'm going to graph a dashed line, and I am going to shade above. So dashed line and shade up. So I start with my y-intercept. My y-intercept is 2. And I use the slope. Go up 1 and right 2, up 1 and right 2. Or again, we could do down 1 and back 2, down 1 and back 2. This is a dashed line. This is the piece that I always forget. And then hopefully you're doing it in pencil because then you have to go back and erase some little spaces. That happens to me a lot. I forget and just draw a solid line out of habit. Okay, so then I want to shade up. So again, imagine being on the line and shade straight above it. That's where your solutions are. Okay. If you wanted to check your answer, you could always pick a test point. Like, let's say I pick, I don't know, what's that? 0, 1, 2, 3, 4, 0, 4. We could take 0, 4 and plug it into the original inequality, that one right there, and see if it gives you a true statement. It should give you a true statement if it's in the shaded region. Okay. Let's look at one more example together. It says Manny has $15 to spend at a fair. It costs $5 for admission, 75 cents for each ride, and 25 cents for each game ticket. Write an inequality for the number of ride and game tickets he can buy. If he buys 10 game tickets, how many ride tickets will he be able to buy? What is the maximum number of ride tickets he can buy, and what is the maximum number of game tickets he can buy? So first, let's write an inequality. Okay, we need to think of the amount of money that he's spending, and we need to think of the amount of money that he has. So I'm going to say spend over here and has over here. So the amount of money that he's spending $5 to get into the park, flat rate. He's spending 75 cents for each ride ticket. So 0.75, we'll call it X. And actually, I should probably name my variables. X will be my ride tickets, and Y will be the game tickets. So 75 cents times each X, then plus 25 cents times each Y. He has a total of $15. And then we have to think about what inequality symbol goes in there. You can never spend more than what you have. So the amount that he spends has to be less than, but it could be equal to. He could spend all of his money. He could go up to exactly $15, but it has to be either less than or equal to. Okay, so there's my inequality. Then in the next part, if he buys 10 game tickets, how many ride tickets will he be able to buy? So then I want to take this 10 and plug it in for the game tickets, which is Y. So I have 5 plus 75 cents times the ride tickets, which we don't know, plus 25 cents times the game tickets, which are 10, and I want that to be less than or equal to 15. And then I can go through and solve this. I'd have 5 plus 75 cents X plus $2.50 is less than or equal to 15. And then I'd have 750, because if I put that with that, 7.5 um, plus 7.75x is less than or equal to 15. And subtract the 0.75. Oops, subtract the 7.5. I get 0.75x is less than or equal to 7.5 there. And then we can take our calculators and we can divide that. I'm going to have 0.75x is less than or equal to 7.5. Divide by 0.75. And all we did really there is move our decimal point, so it's x is less than or equal to 10. So what that's saying is that he can ride no more than 10 rides. There you go. There you have it. Okay. So then in part, the next part, what's the maximum number of ride tickets that he can buy? Maximum number of ride tickets that he can buy would mean that he buys no game tickets. So that means that y would be equal to 0. So if I plug that into our original inequality, that means I have 5 plus 0.75x plus 0.25 times 0 is less than or equal to 15. And then 0.25 times 0 is gone. So I just subtract the 5. 0.75x is less than or equal to 10 and divide by the 0.75. When I divide that, 10 divided by 0.75, I end up with 13 and a third. So I get 13.3 repeating is less than or equal to, or x is less than or equal to 13.3 repeating. Oops, I put that on the wrong side. And we have to consider this being rides. You can't ride a third of a ride. They're not going to stop at a third of the way through and have you get off. So we really can't count that 0.3 repeating part. So I would say no more than 13 rides. So then in the last part, now it's asking you what's the maximum number of game tickets that he can buy. So in this case, that means that x is going to be equal to 0. So I'm going to go ahead and stop our video at that point. I want you to figure out this last part. What's the maximum number of game tickets that Manny can buy? Don't forget to hop back to Schoology and take your quiz. And thanks for watching. I'll see you tomorrow.